We're about to repair the connector, and as I said, we're going to do this professionally. So you need to get a connector kit. The full kit comes with one plastic housing, the 2 pins, the weather packing, and the lock for the pins. The other thing you'll need is a crimping tool and some side cutters and a razor blade. Maybe you'll use it, maybe not. So those are our items. Now let's go to the connector and we'll show you how to repair it. First, we'll remove this old connector, and you need to make sure where the orientation of the pins are. If you switch these around, you're going to have problems in your signal. So here we have 2 wires, looks like a brown and a pink. The pink will go to this side. Then we'll remove this heat shield and we'll cut it short. If this disturbs you too much, you can just leave it out, but I want to return it in. Okay, so that size will be adequate. I'm going to set this to the side first, and then I'm going to clean my wires up just using a bit of home dry cleaner or naphtha. The naphtha or naphtha. And those are our 2 wires, the brown and pink. Alright, now let's proceed to loading our pin. Now this is not as intuitive as you think it is. And that's because the way this tool is made, it's not idiot proof. You will damage a lot of connectors the first time you try this. So what I suggest you do is try it on some dud connectors and pins at first before you do it on the real thing. Otherwise, if you buy just one set, you will end up damaging. This tool has got 2 faces. First of all, you need to know, what are you loading? Are you loading here or are you loading here? If you notice here, there is kind of a bump. That is a telltale sign. That bump is where you load your pin. And if you forget, you'll see some writing here. This is 18 to 16. This is 20 to 18. This is 22 to 20, 26 to 24. So if you see your writing here, there's nothing here. So it means that well is the place you load your pin. Then this has 2 sides to it. There is a narrower side. So if you collapse it completely, let's close it. You'll see there is this side, and then there is this side. Now if you notice, this side is much bigger. So your wire will crimp with this, but your weather pack will crimp with this. That's another important thing. This will give a lighter crimp. This will give a heavier crimp. And I'm showing you to this because it's easier to see on camera, but we are actually using the 20 to 18, which is this slot here. So when you load your pin, make sure that the wire part, which is this one, goes on the smaller crimp. The weather pack side, which is this one, goes on the wider crimp. So let me open this. It's very hard to load this on camera, but what I'm simply doing is loading it. Remember, the dimple side, the part that has the dimple, which is this one, is where you put your pin faces down there, basically. So again, that's my wider side. So this pin is going to look like this. So what I will do is place it in here. Like that. And then you are going to center it. Then give it one click. Once you give it one click, it'll lock. And when it locks, you'll see on this side, you will see the well for your wire, and this side is going to be your weather pack area. Now what you do is you take your weather pack, push it to the end. You're going to thread your wire inside there, and then look on the other side and make sure you see your conductor coming through to the well. It has to reach that well. If it doesn't reach that well, keep pushing the wire until you see it reach there. Because if you don't reach there, you're going to collapse the pin with nothing crimped on it. And then once you reach there, fight with your weather strip, so that your weather pack, sorry, so that it gets inside the end. Now that's going to be hard to show. Now if it moves like this, and it will move, what you do is just put your finger here to stop the pin from moving. You can go another click, but if you go another click, you'll collapse this inwards, and this is fat. It'll be very hard to fit in there. So enough talking. Let me just do it, and then I'll show you how it looks like. Once you're in, you start and you keep going until your tool reaches the end, and then you release. And what you're going to be left with is that. Now that is a good crimp. And let me show you the features of a good crimp. Number one, you will have crimped your weather pack here. Number two, you'll have crimped your conductor over there, and then if you turn your pin like that, you're going to see a very nice marking here. Those three markings, that shows that the tool bit in there and it's secure. And then number four, which is the most important, you haven't damaged in any way this portion. This portion is the locking tab for your connector. This slides into the connector and it locks in there. If you damage this and bend this in any way, you're done. You need to get a new pin, because it will not go into the connector, and if you fight with it to go into the connector, you'll damage the connector. So that is that one. Let's do the second one. Even for me, after doing this all these years, I still need to know where my larger part is and where my smaller part is. It's not intuitive at all, trust me. Now, sometimes this will be too wide. Don't be afraid to just narrow it a bit, but don't narrow it too much. You just want to narrow it enough to get into your slot. Oh, you see that? I'm about to load it into the wrong side. My wider side is this side. My smaller side is that side. So Let me just widen it again because I don't fight with my weather pack too much. And let me turn and remember, you load the connector facing that raised portion. So it's like that. So let me just push this one in, and there. So that's how you load it. And then I come here, make sure it's sitting nicely, and give it one click. That's one click. Make sure that my well, where the conductor goes, is visible, which it is. Give it support so it doesn't move out. Pull my weather pack out. Thread my conductor. Being patient. And thread it until you see your conductor come on the other side, which it has. Now this one is much easier than the first one. I don't know why, but that's a blessing for me anyway. And then once you see your conductor and you're satisfied with where your weather pack is, oh, my conductor is disappearing, let me push it a bit, there we go, and you start crimping. And unless you have Hulk fingers, you won't be able to push this thing in nicely. So I have come out, but I'm still loaded, and it looks like this thing is quite tight. So too much talking. Let me just do this. I don't want to waste my pin. I don't have any more on this set, at least. This was my last one. So thread it in, make sure it goes in. I can see my conductor. Push in my weather pack, pull a bit of the conductor, and I think I'm good. And here goes. And that is my crimp. Now my weather pack on this one didn't go in all the way, it's still caught. Beautiful. Now do not assume you need to give this a nice healthy tug, and that will give you peace of mind that your conductor is in there nicely. If it's not, repeat it with different pins. Of course, you can't reuse these pins. Now remember your orientation in your connector. Let's get our connector. Remember, our brown was on this side, our pink was on this side. So just swap here, and you are going to push this in. It only goes in one way. So if you start pushing it in and it's resisting you, don't continue. Turn it around, like here. Doesn't feel like it wants to go in. That's okay. Take it, turn the connector around. Now it'll go in, and you're going to hear that, a nice healthy click. Then you push in your weather pack in there. Now you need to use something blunt. This one's much too sharp, but I'm not really digging in. And that's how a healthy connection looks like, or rather a healthy insertion. Okay, let's do our next one. Now remember, make sure your orientation is good. If you get it wrong, don't panic. You can release the lock here and pull this out. Now let's try. It doesn't want to go in. No problem. Let's turn it round, or it's easier for me to turn my pin. So let me turn my pin around like that and put it in. You're just going to feel it slide in nicely. Oh, no, that wasn't it. Let me do that again. Actually, my first one was correct. There we go. It has clicked. And then come and push in your weather pack. Now, I'm used to using this pick, so I know how to do it. If you're doing this for the first time, get something blunt, like a matchstick, and shove your weather pack in there. Now, a tip. When this heats up in the engine bay, it's going to kind of swell up. So it'll occupy this space and make it waterproof. You do not want it to swell up when it's outside. That is why you should just take your time and tuck it in there nicely right now before it's too late. Once it swells up, it's really going to stay in there nicely. That is if you get good connectors. If you get these cheap fake ones, then this is just a rubber and it'll remain the same way. Huh? There we go. Nice connector fix, and your pins are there. You're not done yet. One more step. You need to insert the lock in here. Now, nothing really will happen. I've forgotten these locks out sometimes, and I've noticed like a year later, so it doesn't really come out. But if somebody comes here and pulls this thing hard, they will come out. The lock just ensures that those two tabs remain in and don't move. That way you can tug this until the cows come home and it will not pull out. So let's get our lock. This is our lock. Again, it goes in only one way. So this is quite idiot proof. That's the way it goes in. And then you just make sure that it's in its right place. If you push and it doesn't want to go in, don't force it. Find out why it's not. Maybe it's sitting at a bad angle, like mine was sitting at a bad angle. There we go. Hear that? Clicked in place, and look at that. Just like factory. That is what a professional repair looks like. Now, this has taken some time because I'm explaining, but this is a very quick job. Once you are used to it, it's just that quick. And there, now we come and we'll connect here. And you can hear it latch. Now, there's something I forgot to put, and that is my short heat shield here. Now, I'm not going to take this connector apart. Sorry. I'm going to leave this out. This just was supposed to go over there. I'm just going to leave that out. And I'll put some tester tape over there. But that's it. Very nice. And let me show you how it looks like. Now we have a nice factory connection. Okay, that's it. Let's start our car, read our codes. So we're running. Car is running well. So far, no check engine light. That's a good sign. Let us read our trouble codes. And boom, no trouble codes. So that's fixed for that connector for the cam position sensor. Pretty critical connector. I'm surprised this car was even starting. So that leaves our intake leak on the snorkel. I did check my two dealers here. Unfortunately, no bueno. Nobody has it in stock. We'll have to do a quick import for that. But I can release this car to the owner. He can drive this. It will not be good. Let's just quickly check our fuel trims. So there's our trims. We're hovering about -10, -12. Okay. That is a bit too high for me. I don't like that. The other thing is, apart from the fuel pump, it could be that this thing was running lean so much and the injectors were spraying so much that the oil just has too much fuel in it from the blow-by. So an oil change would be in order on this car. In fact, I'll get an authorization from the owner to do an oil change, and yeah, that may solve our rich condition here. It's not too bad, and this will not code because it starts coding at around -24, I think, on this, plus minus 24. But I still would like this to be as close to 0 as possible, so I'm not quite happy with this. Anyway, that is it for now. I'm going to do an oil change on this and then report back what I find after doing an oil change. But for now, I think we're done. Alright, a quick one here, and I think this is really cool. Guys, we've always been taught that a vacuum leak causes a rich condition, right? Yes, it does. Why? Because we have unmetered air going into the engine. So the engine calculates the fuel quantity from the mass airflow, injects that quantity, but there's some extra air coming in at the intake, and then the computer compensates that by adding fuel. You see a lean condition. But here's another variable. That is true if you are behind the throttle plate. Why? Because behind the throttle plate, that's where you have vacuum. What about here? There isn't much vacuum over here. This is just airflow that's rushing in. It's not really a vacuum as such. I want to show you guys something I've just learned right now. Check out our fuel trims. You can see we're still running rich, about 13% or so, 14%. Now, what I want to do is to block off my breather hose here, and then I'm going to disconnect this and look at my fuel trim, and we're going to see something interesting. So let me bring this here. I'll focus you on that. I'm just going to come here. I'm going to disconnect this and quickly patch it. It's going to disturb my airflow here. So there we go. Now check this out. How cool is that, guys? Now I want you to pause this and think, what exactly is happening here? How come our fuel trims have normalized? Basically, in our case, we buy a new snorkel, we are done with this car completely. But how do we explain this? So this is my explanation for it. If somebody has a better explanation, I would like you to put it in the comment section, but this is my explanation for this. And let me do this again. And check that out. Now we are rich again. So this is my explanation. There seems to be a way in which the mass airflow reads that is dependent on the integrity of this hose. If this hose is leaking, like in our case we are leaking here, then it changes kind of the way air moves through here, and it gives it a slightly higher reading than normal. Let me test that by pulling my mass airflow reading in grams per second. So there are my data feeds updated. I've just added my mass airflow here, and right now you can see it's 1.7 grams per second. And look at my long, look at my short. Now let me do the same thing. Clamp this off, then quickly block. Look at my mass airflow. It's actually going down. How cool is that, guys? So I think that's pretty neat. So I reckon the way this is acting with this leak here, the way air is moving in this box is not being sensed correctly by the mass airflow. And that is why we are getting our fuel trim numbers like this. So before doing anything, I would want to get a new snorkel and change it and then revisit this. Alright, we're taking this baby out for a test drive. I've been driving for 20 minutes and feels good. No hesitation. A bit of a funny pull on gear 1. I think there's a transmission issue with this car, but I want to go up this hill and do what he could not do. He could not floor it uphill. He could not overtake. So far I've been able to drive well. Look at my speed right now. But of course that's assisted by downhill. Let me slow down a bit and let me take off going uphill here. And I'm building up speed nicely. Look at that. Excellent. Well, this guy is good to go back to the owner. The only annoying thing is that low fuel warning will remain on all the time. And this tank is full. I told him to fill it before he gets here. So let's just quickly look at that sending unit circuit and see how it is. But I like this. This is really good. Alright, let's go to the wiring diagram. You go to the engine. We are 1AZ FSC. Alright, here we have the fuel pump, but this only shows the powers and grounds, so we want the whole view of that sending unit. What we're going to do is to come here to connector view, and we're going to search for connector N16. And N16 is found in the engine control, also found in the combination meter. So let's go to the combination meter. Okay. So here we have N16, fuel center gauge and fuel pump. So there are two options here, 12 and 5. Let's look here at the options. 12 is 1ZZFE, 1ZA, oh, it's 1AZ FSE. So we are going to option 12. We have on pin 1 yellow and green, and that is FU positive. Pin 3 red and yellow, FU negative, and pin 2 white and red, FUA. Now, one of these is going to send a positive supply, and one of these is a ground. So this is a ground, this is a positive supply. I don't know what the supply is. And then this is just a simple potentiometer. Then the potentiometer trims that voltage down and it sends it on FUA. So the easiest thing to do is for us to go to our sending unit. I'm going to disconnect this wire. The first thing I'm going to check is, do we have our supply feed here? And what supply feed is it? Then do we have a ground? And then if we have our supply and our ground, we're going to put a variable resistor here and then send a variable voltage on FUA line and see if our dash is going to report. So here are my connections. Channel A is FU positive, that's the power supply to the sending unit. Channel B is FU negative, that is the ground supply to the sending unit. Channel C is FUA, and I think that is fuel available, so that is a signal wire. So we're going to put the key on. And we have the power supply. It looks like we do not have signal, and we have a ground. And I think I want to check whether the ground is shorted to the signal. So we're going to start the car briefly. Okay, as you can see on the scope, the ground and signal wire is continuous. So this is a shorted sending unit. Now what we want to do is to test whether our dash is going to be able to receive the signal if we put a new sending unit. So what we're going to do is to come here, take the potentiometer, and we are going to tee in our potentiometer in these three wires. The red will go to the power supply, the black will go to the ground, the blue will go to the signal wire, and we will pot the signal and give it a fake signal and watch the dash and see if our gauge will come up. Our gauge comes up, we are done. We need a new sending unit back here. If our gauge doesn't come up, then we have something wrong with the cluster and we need to go to the multiplex computer and find out what's up. That coming up next. So there's my potentiometer. Now, since our sending unit is shorted, we need to completely unplug it. Otherwise, our readings are going to be deceptive. So we have unplugged and we're going to put the key on. Key is on, and I am going to give a potted signal here. So I'm going to turn my trim pot, and the red channel on the scope, not the red channel, the green channel on the scope should go up. And then it takes a while because there's a padding between the time the signal hits the multiplex computer to the time the gauge reacts. And the reason why that is the case is so that when you're driving and the gas is sloshing around in the tank, you don't want your gauge to swim up and down with the waves. You want it to remain steady. So there's always a delay padding. So I'm going to add my potentiometer as you're watching the gauge. Here we go. So there, let's leave it there. And we're going to watch our fuel level on the dash. It'll take some time because there is a delay and there's a pad. Okay, our dash is reacting. Let me go up more and see if I can go to full. And we are going up. It looks like our multiplex computer is working, our dash is working, and the signal is able to be interpreted. Let me go up a bit more and see if I can go the whole scale and sweep it up to full. It's important we go up to full because the last thing you want to do is to put a new sending unit here and then the client complains that the gauge doesn't reach full. All right, that's it. We've reached full. We are done. New sending unit. and this will fix the car. That's it. Another one for the books. Until next time.